Hello everyone, welcome to the first coding video of a series of remaking Getaway Shootout. Getaway Shootout is a game that I've previously made, and the goal of this series is to make kind of a small subset of code to share with you all. So if you're interested in making the game for yourself, you can follow along and also download the code on the Git repository. So I think the goal of this video today will be to do the player movements in the game, and I'll just show you quick kind of the overview of the player movement. It's pretty simple. It's a 2-button movement, so if you press the W key you turn left, and then once you release you jump, and the same as with the E key you turn right, and then once you let go you jump. The other thing to note is the player is automatically balancing. The player always tries to stay upright while you move, except while you're turning. And that's basically it. Gives you a nice movement to kind of navigate a level, and it's nice and physicsy. I guess one thing to note is, the movement was inspired by soccer physics, so definitely check out that game if you're just interested in games that use this movement. So that is basically the whole movement. Let's get into actually coding it. As I said before in the intro, this series is kind of going to be laid back, and I'm going to be just trying to refactor the code from the original game and just sharing with you the process of doing that. So let's just get into it. So jumping to the project that we created in the first video, this was just an empty project with just some sprites, and importantly we'll have the sprites for the player, which we'll use. To start off, let's just jump into kind of an overview of what we'll be doing with the player movement and what we want. So the goal is just to create the player movement for the game. And as I was showing, the player movement is kind of separated into two separate ideas. So the first is just the turning and jump. And this is where the player is obviously turning when they press a key, let's say like the W key. And all this is kind of relative to an angle, and we define the angle just as the vertical line with the player. And that's important because in the code I set kind of a max turn angle. So from this line you could have like 2 lines coming out. This would be your max turn angle. We'll define it as theta. Doesn't really matter. So basically the player cannot turn past that angle, and once they reach that angle they'll stop turning and just be fixed on that angle. So that's just a simple jump, or that's a simple turn. Obviously when we get to a certain angle and we let go of the key, we're going to want to just add a force up on the player to make the player jump. The other kind of main mechanic of the player movement is just the balancing feature of the player, and this is when the player is not moving or not pressing a turn key like W or E. And this is just going to make sure the player is as close as possible to the upwards normal line. So the way that this kind of works is to define another angle, and this could be a lot closer to the actual the line that is upright. And basically this, we'll call it maybe phi or something. This is the angle that is a zone that we are upright. So if we're not in this zone, so any angle, say if we're out here, we want to get back into that zone. So we're always going to be applying a torque to get back into it. So anywhere we are, just apply the torque to get back into that zone. If we're in the zone, don't apply any force. And as we'll also show, maybe when we first enter this zone, we'll add like a small damping factor to slow down the player so it doesn't overshoot as much. That's basically it for just kind of the overview of this movement. And obviously it can be implemented a lot of different ways, maybe even using like a PID instead of this kind of algorithmic approach of just adding force. But as we'll get into it, I'll show you just a simple way to get started. So now let's jump back into the project. So the first step is to actually create the player object. And I actually went ahead and created the player object already because in a previous recording I found it a bit tedious and a bit boring to do it live. So I created a prefabs folder. This is where it's going to store all the prefabs of our game, and then just included a player's subdirectory. And so far what I have is 2 prefabs, and the first one is this base player prefab, and I'll just double click it to kind of show what is currently in it. The idea for this prefab is just the graphics of the player. So just running through of what I created is obviously the prefab, and then I have a body child element with the actual sprite, and then an arm pivot. This is where the arms could be pivoting around, and the arm sprite, which is what the arm is rendering. And these sprites are all from the previous sprites I imported, the players and sprites. And then finally there's a holding spot. So the reason why I created this kind of base player prefab is this allows me then to, if I want the player in the background or in the menu without any rigid bodies attached, I can have this player just easily in the scene. And then also when I make changes to the player, if I need to, all the players will be updated. So that's our base player prefab. And then what I did is to create a prefab variant off the base player, and then this is going to be our ragdoll player, which has all the physics applied to it. Obviously, all these terms, prefab variants and such, can be confusing to a new Unity user, so definitely check out Unity tutorials on all this. As I said in the first video, this is more of kind of my process of going and remaking this game. So in the ragdoll player, it's just a prefab variant, and the things that we include, it's shown in blue. I added a box collider and a rigid body to that player. And something interesting to note is in the original game, I chose a gravity scale of 1.5 for the player. And it's kind of an interesting decision because the objects in the scene have usually a gravity scale of 1. So if you've noticed, players do accelerate faster than other objects. So this could be changed to 1 and then set like a global gravity scale value. But I'm just going to keep it how the game did it and set this to 1.5. And also the other change I made to this prefab is to make the arm physics enabled. And that's adding a box collider around the arm and then a rigid body attached with a hinge joint. And the hinge joint is basically the physics element that calculates all the rotation around the joint. and this is just connected to the main rigid body. So in total, there's 2 rigid bodies on this player. And yes, so that works. Now there's some small changes that I want to just say I want to do live is for the body sprites. It's nice to have them on a separate layer in the Getaway Shootout game. The player sprites are all on a separate layer, and this is the sorting layer that I'm talking about. So when I imported it in, it didn't have the sorting layers added, so I'm just going to add a sorting layer right now, and I'm going to call this layer player. So I'm going to move the body sprite to the player layer and also the arm sprite to the player layer. And like I was just saying, this just makes it so all players will be rendered on the same layer. That way you won't have players accidentally going behind sprites when you don't want it to. We'll add more layers in the future, like a foreground layer and a background layer, but for right now we'll just have those 2 layers. Okay, and then jumping back to the ragdoll player, the other addition I want to add is just to make sure that this arm doesn't interact with any sort of colliders. That's how I had it in the original game. It doesn't need to be this way, so you don't have to add this. But I just found it easier if the arm doesn't interact with layers. So I'm going to create a new layer. This is just a layer component. And layers will, you can define physics collisions with them, so that just makes it easy. And I'm just going to do, call the layer called arm. And so the whole arm pivot, I'm going to set to this new arm layer, and I want to change the children so that all the children have this arm layer. And that's great. The only other thing we need to do is jump to the project settings and edit this kind of layer configuration. So all we want is that the default layer and the arm layer don't collide. And that's the kind of functionality that we want with the arm. Another thing we don't want is the arm to collide with other arms. But like I said, if you want this kind of functionality, you can keep it in. And that's about it. So I'll just keep the rest of the settings as is, and it should automatically apply. As I was looking through kind of the new Unity system, I did see the layer override section. So it would have been possible maybe to do it something in here instead of creating a whole nother layer, but I think this is a fine solution. So jumping back to now our 2 players. So I just want to test out this ragdoll player. So to do that, I'm going to create a little ground object, and actually I'm going to use the square sprite that I imported in, and basically I'm just going to have just a test ground object so the player can rest on. So that's going to be our ground, and the other thing would be to now import this player into the scene. This is just going to be a simple drag and drop of our ragdoll, and that looks great. So now I just want to test if this ragdoll is working. So I'm just going to set it up at a different angle and press play and see if it falls down like we expect. Okay, so that's great. As you can see, the arm is not colliding with the ground, which is exactly what we want. But if you don't want that, you can definitely just not use this arm layer. And the player falls down, and that's exactly what we want. So with this now in place, the next step is to add the player movement script to this ragdoll to make it kind of bounce upwards. And the goal would be to do something that, like, you can't really, oh, there we go. Get it to bounce back up and automatically, orientate itself. So that's what we're going to do next. So I'm going to remove this from the scene. And I could just do this on the ragdoll object, but I want this ragdoll object to be as simple as possible, just to have the physics enabled components on it. So I'm actually going to create another prefab variant from this prefab variant. And I'm just going to call this the player. And this is going to be the object that contains all the player movement, and as we'll see later, the player power-ups, everything that manages the player. So I'm just going to open up this player object, and the first step I want to do is to actually add a player movement script. And I'm just going to add that in. And actually, so it defaults to putting the scripts into just a default directory. So I'm just going to actually create a folder called scripts and drag the player movement into that. And now I'm thinking about it, I think it would be nice just to have a player subfolder for all the player scripts. So I'm going to do that and drag it into that. Okay, so now I think our first step would be to do the player balancing, and just jumping back into kind of the diagram. So yeah, we want to first just try out kind of just the player balancing and get that working. The only parameter that we really focus on is this phi value, and that's going to be kind of like our balance zone angle or something, and that's going to be the main thing kind of associated with balance. There'll be other parameters, and I'll just kind of add them as we go. So I'm going to open up this player movement script, and I'll just delete this template code. So I'm just going to look at the previous game player movement and kind of get a start from there. So one important thing when you're dealing with physics in Unity, I think it is recommended that you do it on the fixed update if you're doing any changes to the force or to the torque or any adjustments to the physics system, instead of just the normal update. So that's what we're going to do here. And our goal right now is just to create a sort of balance function. So I'm just going to do a function called balance, and basically on the fixed update we just want to balance, and call this all the time for right now. Okay, so now in the balance function we want to get our rotation, and there's multiple ways to get the rotation. In Unity. I found it helpful just to create a function that kind of does this for me, because we'll be using it a lot, and I want the rotation specifically to be implemented in that way that it's relative to that upwards line that I mentioned earlier. So I'm going to create a function that has get rotation, and in this function is where we're going to do that calculation for that relative angle. And this is basically a pretty simple function that we want it to be from the rigid body. So I'm going to actually do a component up here called rigid body RB, and then on start just set this rigid body. Sorry, I'm kind of going all over the place. kind of trying to balancing following the previous code and implementing it here, but hopefully it's not too confusing. So with our get rotation, we want to get the rotation of the rigid body. You could also use the transform here. You do transformer, Euler angles, and use the Z component, but I find it easier just to use the rigid body rotation. And also we're doing it on fixed updates, so if our rigid body later is interpolated, it's better to use the rigid body values than the actual transform values, because the rigid body values will be currently updated values. So we'll say so rotation dot z. Oh, and also we want this to be a 2D rigid body. Okay, so we couldn't just return this rotation, but the important thing is I want it to be that relative to that angle. So I'm going to send it through a function to make sure it's between 0 and 360. So this is using the math.repeat function. And honestly, I should have looked at the documentation, but this rotation value might already be in this format. But this is just going to ensure that it's a value between 0 and 360 degrees. And I want it, so 180 degrees is where we're facing down. And at that point, I want it to be a negative value, meaning that it's to the left of that reference angle. So I want values greater than 180 to actually be subtracted and put to and made to a negative value. So let me do that here. So if the rotation is greater than 180 degrees, just minus 360. And I didn't explain that great, but let me just show you what I mean here. So currently our rotation is going to be some value between 0 and 360 degrees. And basically 0 is going to be the upwards direction, and any point along this is going to be a value. And obviously 359 would be something right there. So I instead want it to be a relative to this angle, and instead of this being, let's say, 330 degrees, I want it to be negative 30 degrees. And over here, if this is 30 degrees, I want it to be actually just, same thing, 30 degrees. And what that code was doing that I set up is to actually just subtract it to make sure it's always relative to that vertical angle. So basically all this does is have an angle between 180 or negative 180 and 80, with 0 being vertical. Okay, so that's our rotation, and we get that in the balance function. So now with this rotation, fix that. We want to apply the balance function basically in relation using that angle. So I'm just going to define a public variable, and I'll see what I called it in the previous script. I think a good name for this is going to be max upright angle. And this was that phi angle that I was talking about before. And let me see what I set it to in the actual Getaway Shootout code. And this was randomly chosen at 7.2f. So this is just, that angle that if we're not within that zone, we want to apply this balance function. And this can be done in a simple if statement. So if the ab absolute of this rotation. So if it's greater than the max upper angle, we want to balance. And the balance code is going to be a pretty simple code for right now. I'm going to say, let's see, we're going to have an amount to rotate, or I guess objectively, so we want it to apply torque in the end result. So I'm just gonna do that now, add torque, and the torque amount is something that we're gonna need to adjust. So I'm actually going to do another float, and this is gonna be the balance, let's say balance power, and we want to add torque, but this will always be whatever the balance power is set at. We want to be in a relative direction, so we can actually use this rotation value to get to multiply to get the actual direction we want to. And so that's going to be, I'm just going to make it another variable, and this is going to be direction, and then maybe just call it direction power, and this is just going to be the negative of our rotation. So I can multiply these two together, and it seems weird right now that I'm just adding and setting this variable, but I'll make it, there'll be more stuff added to this later. That's why it's set to that. So we then multiply these two and add the torque. So this will always try to get us back to the balance point. So I think this is good enough to actually test out. So I'm just going to jump back into scene here, and let's see if I added that. I did. The balance power is actually a variable I'm going to set, and let me check in the code quick of the actual Getaway Shootout value. Okay, found it. So I'm just going to set that here. And importantly, the Getaway Shootout value, or the value won't be set in your editor if it's a public variable. So you have to set it again, and that should be good. So now let's test this out quick. And I'm just setting at an angle just to see if it'll adjust upwards. So if I click play, yes, so you can see it is working, but definitely very overkill, or it's like adjusting way too fast. And this can be a power setting, so if I turn this down to like something a lot smaller, and then, but you can see it definitely still is overshooting a lot. And I guess when I was making this, I came up with a simple solution, but this does seem like a problem that like is rooted into something called control theory. We want our player to always try to be approximately that zero angle. So there's definitely a way you could go about this that is, player just fell off the map. You could definitely do this using like a PID loop or something like that, but the approach I did is somewhat equivalent to it. So right now we want to have this overshoot be disregarded. or we want it to kind of minimize this overshoot. And a quick fix to do that is actually to just use like a damping function every time we enter this zone. The first time we enter the zone, we want to apply a big damping so we slow down a lot for that first frame. So I'm just going to do a variable. I'm going to do like has applied damping. And I might change these variables later at the end of the video to make it actually make more sense. But for right now, we just want to use this variable. So if we're in this range, we want to set this variable to false because we're actively trying to rotate the player, so we have not applied the damping yet. But if we're in the range, check if we have applied the damping, and if we haven't yet, well, apply damping then. So in the case of Getaway Shootout, I applied damping by just directly modifying the angular velocity. So this is just a simple function that is changing the angular velocity. I'm not sure if this is great to modify it directly, but it was an easy way to change it. So I'm just going to set the angular velocity to angular velocity, but divided by some large amount. So this will significantly decrease the angular velocity the first time it reaches the frame. And there might be better ways to actually damp it, not actually using the angular velocity, but this is what I did in Getaway Shootout, so we're going to stick with it for right now. And importantly, we want to set has damping to true. So this means then we only apply it for the first frame. We don't want to keep applying it while we're in that range. We just want a one-time slowdown, and we'll see how that works. So let me jump back to Unity, and I have the same player setup, and let's see if this will better balance the player. Okay, so I did it quickly there. Let's see if I can just manually rotate the player. I'm just gonna pause actually quick and rotate it. Let go. Oh, so Unity does bug out a little here. Let me just reset the whole game and do it from the start. Okay, so the player is going to be falling down like this, and went a little fast, but it does look like it's better, not as quick, but there is still settings that, oh, it's doing it while we're not even connected. So this was actually, I crucially missed out on one piece of the code that is pretty important. So in the game Getaway Shootout, you only rotate upwards if you're touching something. And currently right now, it's doing that while it's just in midair. Obviously we don't want that. So an easy way to fix that is to kind of use a function to determine if we're in contact. And Unity provides nice functions for on contact or on collision. And basically this will tell us when we hit something. And I'm actually going to have another variable called in contact to let us know if we're in contact. So if we hit something, we're in contact. Now, if we leave a collision on collision exit, we are no longer in contact. And I haven't fully tested this code. Getaway Shootout actually uses on collision stay and just calls a function from there continuously. But I think this is a cleaner approach. My only worry is like if the in contact misses the on exit, but I think this will work. So let's go with that. And the only change to the code that we want to do is we only want to apply a force if we are in contact. And also, we only want to reset that variable to if we have applied a force. Let's keep it like that. Basically, forces are going to be applied. Once a force is applied, then we reset to allow damping to occur. And that looks great like that. So let's just test it out now. Okay, again, we have this player situated upwards. And let's see if it hits the ground, then rotates. Okay, so it does, but the player shoots up way too fast. So one thing is the balance power might not be set correctly, and I guess that is the case since in the code I do a little bit of a difference. And maybe I'll just get into that right now. So okay, I just checked to make sure that the code wasn't wrong with the actual Getaway Shootout because I want to make it close as possible. But it was just value was wrong with the balance power. This was actually set to be 0.3 in the code. So if we try that, it should give a movement actually very similar to Getaway Shootout. Okay, so that looks great. And that's updating good. So the next step would be to, I guess, make just small changes to the bouncing. Actually, let's move forward to actually getting the player to rotate, since the bounce seems pretty good right now. So with rotation, we want to rotate whenever we're not, or we want to do the rotation when we're pressing the input keys, and otherwise balance. So I'm going to set up kind of a function right here under balance. I'm going to call it maybe turn is the better name for this. And basically we want to create kind of that logic here to decide if we want to balance a turn. So if we are turning, obviously turn, and then otherwise balance. So that's pretty simple. I'm going to create now a variable bool is turning to determine if we're turning or not. And let's do, so this works all great. Let's make a function to actually start turning. So turning this variable to true. And I'm going to do it down here. And I'm actually going to make it public because later we want to be calling this from our player input scripts. And also the computer movement wants to call this. So let's do this, public void start turn. And importantly, with this function, I'm thinking we want to pass in the direction that we're turning. So I'm going to give this a bool, and I'm going to call it turn right. And this basically tells the direction to turn. And I'm going to create another local variable up here actually to just save this variable to turn right or not. So I'm going to just call it turn right as well. And basically we want to set the turn right to the variable that we pass in. And I use this using this keyword to make sure we're setting the right one. And also we want to say that we are turning now. So is turning equals true. And that seems pretty good. We do want to have some more checks though. So if we are turning, we obviously want to return. We do not want to start turning a different direction while we're turning. At least that's what I did in the Getaway Shootout code, to have that functionality. And also one big thing that is missing is we don't, at least in Getaway Shootout, we don't want to turn when our feet are not on the ground. So I'm gonna have a function down here and call it is grounded, and basically we're gonna complete this in just a little bit, but for right now let's just return true. So if we're turning, return, but if we're also not grounded, we also want to return. So we only start turning if we are grounded and not turning. Some small other things to set this up is basically we want to lock our player's rotation when we're moving. So we're gonna have to set the rotation to be constrained, and this is just using Unity rigid body constraints, and we set constraint, and this is just gonna be freeze the rotation. So this just makes sure that gravity doesn't change our rotation, and we are only changing the rotation in this turning phase. Okay, so that seems good. That's the start turn, and this will now call the turn function, and this is going to be kind of the main function to actually update the player's rotation. And we'll start off simple, and all we really want to do with this is to get the rotation. And that's just with our function that we did before. This is, again, relative to that up angle. And we also want to know what direction we're turning, and that's stored into this turn right variable, which is good. And that seems good. With all that in place. So the way to set a rigid body rotation, there's multiple ways, and the way I chose is to actually set directly. And thinking about this more, this might not be the most ideal case again to set something directly, but when I was testing and also just in the game, it's worked so far, so I'm just going to keep it this way. So we want to set the rotation, and we want to set it to the current rotation plus some small change in the direction we want to go. So that small change is just going to be related to some variables. So I'm just going to actually create another variable up here, public float, and we'll call it the turn speed. This is going to be how fast we turn. So we want to plus the turn speed, but importantly, this is not a, well, I guess the most important change is that this is only one direction again. This is just a magnitude. So we want to actually go in the right direction. And one easy way to do that is actually just to have a variable called direction, and we can set it to the rotation. If it's greater than 0, we set it to -1. Although, or wait, I'm thinking of it in the balancing scenario. We actually want to depend on the turning right. So if we're turning right, we want the rotation to increase 1. I could be wrong on that. And otherwise, we want it to multiply by -1. And this is just a simple way to get the direction from this Boolean variable. This is just a special C# operator that basically converts the bool into a 1 or -1. Oops. So I'm just going to multiply this by the direction. So now this should be working fine. But the one important change is I'm actually going to times it by the fixed delta time, because we don't want this code to be frame rate dependent, and that's how you avoid the issue, is to actually multiply it by the amount of time that's been changed. So with all that being put, that should be fine. Now, I know just looking at this, this is going to exceed, this is just going to keep rotating, which is what we don't want. As I explained earlier, we want a max rotation. So I'm just going to define that up here to have a max turn angle. And let me check what I set this for Getaway Shootout quick. So it seems like we set the value to 53.5, or yeah, there we go. And now I'm just going to implement that logic to make sure it's not over rotating. And jumping back down to here, I'm going to, let's see, check it with an if statement. And I found a pretty nifty way to do this, just given the code. And I'm just going to copy it for right now for my previous code. So if the rotation is greater or equal to the max turn angle, I guess just greater is fine, times the direction. And then, so with this being said, this works. Let me just format this correctly. This works, but importantly, this is only for one turn direction. This doesn't take into account the left direction and right direction. And I don't know, just looking at this, let's see if we can tell. So turn right, that'd be 1, and this is rotation. So this would only be for like the turn left case. And a nifty way to do this is to actually check it equal to the turn right case. So this is actually what we want. It's a nifty expression that checks based on the turn right. I'm just going to go over that. I can come back to explain that more. But with this in place, this should be enough to actually turn. The only thing I'm forgetting is to actually call it from the script here. So we want to have our keyboard to set the is turning and for jumping as well once I implement that. So ideally I want to put this in another class, but for right now it's going to be fine if we do the keyboard. So this is going to be using the Unity input system. This is the new Unity input system. And I'm just doing a quick check if the W key let's see, gotta check which value that I want. If the W key is, I think there's like a press this frame, was press this frame. I'm pretty sure that's the value for on its initial press. So if that is pressed, we want to start the turn, and we want the W key to turn left, so I'm going to say false, and just going to copy this and make an else statement. So I also want to check if the E key, these are just the keys that I assigned in Getaway Shootout. It could be any key that you want. If the E key was pressed, we want to turn right, and then so I'm just going to pass in true. So start turn, and then have it be to the right. Okay, so that's going to be the simple turn script there. Let me jump back to the code here. So I just want to test if this works. Most cases it doesn't work right away. So player is balancing fine. Now let me just press the E key to turn. Okay, so E key didn't do anything. Let me try the other key. No. So let me just quick debug to make sure that this is being called. I can, if this isn't working, I can just double check the Unity documentation to make sure those are the correct functions. Okay, so it was, okay. So something did happen. To update that, that's good. Okay, so another mistake, sorry, plenty of mistakes, but I obviously didn't set the turn speed, so the turn will not work if there's no turn speed. So let me just set to the turn speed that Getaway Shootout uses, which is 280. Randomly set just off of just playing around with values. Okay, now let me try this to see. Okay, so that's looking a lot better. And you can see it turns to that max amount and then stops after that. Great. And I guess I did change this to flip around to make sure it's going in the right direction. So turning right will be in the negative direction. This does seem wrong, but I guess, yeah, the rotation is inverted. I'm always thinking clockwise, but yeah, so that works. Okay, so at this point we have the player to move, and oops. Okay, move. And from this point, the last thing to do is to actually jump. So I'm going to make another function here to do the jumping. So jump, and then I'll give it another variable to say jump right or left, just to make sure that this is calling for the right direction. So if we're not turning, don't jump, because we should only jump after we start turning. So return. Also, if the jump right does not equal our jump or our turn direction, turn right, return. This would be like if we're trying to use the jump key for W while we're turning right, holding E. So we just want to ignore that case. So that seems good to check those two constraints. And the next thing would be to actually apply the force. So we can use the rigid body to add a force, and this is basically you just want it to be in the upwards direction. So I'm just going to I'm going to use transform dot up to be in the up direction, and we're going to times this by, well, another variable. So we're going to do another public float jump power, and let me check of what we set this in the actual code. So in the actual Getaway Shootout game, this is 11. So multiply by the jump power, and so Unity has this force mode, and since this jump is just a one frame thing, we want to kind of almost be just add an impulse. There's actually a mode for that, so I'm going to do force mode dot impulse, and it's complaining I think it needs to be 2D. So that seems great. One thing I do notice here though is we only want to do this force again if we're grounded, and basically we could become ungrounded between this and the actual jump. So when we start turning till we actually jump, so we want to check again if we are grounded. Only apply the force, and regardless, even if we're not grounded, we still want to reset the variables so that we don't get stuck in a turn state. So I'm going to say is turning to false, and the turn direction can just stay whatever it was before. Another important thing to set is the actual constraints that we set before. So before we had the constraints of freeze rotation, we just want to turn it back to what it originally was, and that I believe was just none, since our player originally doesn't have constraints. Okay, so that all looks good. Let's test this code now to have the jumping implemented. Oh, and also I just forgot we have to use the input for this. So I'm pretty sure and this input code is going to be changed in the next video to actually use the input system, but for right now we're just going to do W key, and I want to see if it's released. So they do have, okay, was released this frame, and we want to jump, and I'm going to give it the direction of, well, this would be the left direction, so we'll have it false. And then else if obviously we want to do the same thing just with the other key. If it's released, we want to jump as well, and in the other direction. So that should call the jump code now. Let's just double check if this is working in our code. Okay, so bounce looks good. Now I'm going to rotate one direction and let go. Okay, so jump seems to be fine. Now I can just do not the full direction. If I just tap the button, it doesn't fully rotate, and then I jump. So all that is looking good. Now the thing to notice is we haven't set the is grounded. So you can turn in midair, which is definitely not what we want to do, and you can also jump in midair. I can just spam it right now. It might be a cool mechanic for some game, but In Getaway Shootout, we don't want that to be the case. So this is just going to use the isGrounded function that we haven't implemented yet. And to implement this function, I'm going to, I'll create a variable down here and call it transform. Okay, so I'm just creating a variable that's called our raycast holder. And the idea of this is I want to have some positions on our player that we're shooting what Unity calls raycasts to check if we're near ground or pretty much touching ground. So that's what I'm going to do. So I want to loop through. The idea was also that this raycast holder, we could make it, yeah, that's probably better. Let's do it as an array. And let's do raycast spots maybe. And this will just make it so I can do multiple raycast spots. And let's just do that for right now. So I want to loop through these raycast spots, and this is just using a for each function. So for each spot in the raycast spots, we want to shoot out array. And this is using the physics 2D.raycast. And basically, this raycast just has some input parameters, and the first one being where do you want to start this raycast at, and we want to give it the position of the spot, and then now the direction could be implemented in different ways. Let's use the actual raycast direction, the raycast spot, instead of just the player direction. So I'm going to do spot.up. And actually, I want it to be the down, since we'll just default it to down. And also, let's give it a little distance. So we don't want this raycast shooting like a long distance and saying we're grounded because we collided with something far away. We want it to actually be very small because we want it to be just short distance. And actually, I'm realizing some of this is maybe a little abstract. So let me just quickly draw what this whole raycast idea. So what I'm thinking to check for is grounded, say if we have our player, I want little transforms that basically are at the bottom of the player, that this is the spot where we shoot the transform at. So this is where we start the ray. And then basically at the ray start, we shoot a ray downwards and see if we collide with like something like a ground object. And what I was saying is we don't want this raycast to be too long, because otherwise you're going to be in midair and you're going to be grounded while you're in midair. So we want it to be pretty small rays that shoot out from this player at the bottom. And this will just tell us, yeah, if these rays hit anything, yeah, we're then grounded. And we can then use that. So jumping back to the code, we're shooting these rays. If any of them hits, we are grounded. But I'm just going to clean this up. But if all of them miss and don't collide with anything, return false. We are not grounded. So that's just a easy way to use multiple spots for checking if we're grounded. The reason why I'm choosing multiple spots here is let me jump back to this, is because our player, I'm going to jump to the player object. Let me first apply all the overrides that we did. Okay, so the reason why we want, players rotated, let's see if I can undo that quick. I guess, yeah, it doesn't really get saved. It was, anyways. Okay, so the reason why I'm thinking multiple raycast spots would be nice is because, say if you're at the edge of some barrier and you, I don't know, just the heels touching, we want like a raycast shooting from the bottom of the heel, because that part is still grounded. And the same with the front. If only our front is on the ground, we'll be able to tell if we're grounded just in the front of the player. So I'm going to create these raycast spots. And I'm going to create kind of just a collection of them. So let's go call each one raycast spot. So the first one is fine to be just right there. One thing to know, I'm going to move this just slightly below the actual player's collider. I think a value such as that will be fine. This is just because currently the way the project is set up, any raycast starting inside the green collider here is going to just return true, and it's going to collide with itself. So we just want it to be starting just outside the collider here to avoid that problem. You can change this in the Unity settings, but I think it's going to be fine if we just do something like this right now. Now let me check quick the actual positions of the raycast here. So in the actual Getaway Shootout game, I do 3 raycast spots, and they're all spaced 0.275 apart, and with the middle one being at 0. So just gonna put that into there. Okay, so now we have 3 all evenly apart, and yeah, that's exactly what we want. So we have 3 raycasts. And the last thing to do is just to add it to our raycast spots. So I'm gonna make this locked using the lock box. This will just keep the inspector up, and basically now I can just select all 3 at once and add it to this list. Hopefully, wait. Pretty sure you can. Okay, there. Now I added all 3 of them at once, and that should be now checking for all 3 raycast locations. Okay, so now let's test if this works. Hold on, let's see. Okay, so now let's test if this works. Player falls to the ground. Let's try jumping and then jumping again. Okay, so I'm trying to jump while I'm in air. It doesn't work, but when I'm on the ground, it seems to work. And you can see sometimes, like, there's cases where it misses. It seems like it's missing more than. There's cases where it seems like I'm grounded, but a raycast doesn't hit. Like right there, I tried to jump. It seems a bit more sensitive than the actual game. Let me check if the distance here. Perhaps I use a slightly larger distance. Let me check quick. Okay, so it seems like the distance is fine. but it is still running into slightly issues where it's not being able to. Yeah, so currently the player is missing some of the inputs when it's grounded. Such as, oh, I wasn't clicked there. And actually, I think the case here is not because the grounded. I think this actually the sensitivity of the grounding is fine. More of the issue is actually the way I'm inputting this. So I only do this on the was pressed this frame. I think I'll double check currently right now, but I think having it checked just that frame is making it a little too sensitive. So let me see an actual code if I do that. Okay, so I just checked the actual code, and it is always checking not just the frame but all the frames. So I'm gonna say if it is pressed, then call that function. So this change actually will be fine for our code. Because our start turn function just returns right away if we're already turning. So it will actually be fine to call it every frame. And this will kind of solve the problem of basically missing some turn input signals. Because before, basically, there'd be cases where the player wasn't grounded but very close, and if the player presses a little bit too before, then it completely misses. But this way now I can just hold the button and then it'll start turning once I hit the ground. So yeah, you can see that here. That's working. Now that's basically pretty much all the code for this player movement. You can see it looks a little different than the actual game, and that's because there's a lot of small little factors, or a few factors that are still actually left out of the code. But that is like a good start to sort of the movement. Now let me get into just adding those small factors. The first one being is the player speed, the player turn speed. This seems a little too fast, and the reason for that is in the actual game I lerp the speed, so that means I start turning at a speed of 0 and then slowly increase it into a max turning speed. And so I think that'd be something that we can just implement right now. So instead of saying this to be the turn speed, I'm going to say this to max turn speed, and I think it was 280 is what we set it to before. I don't want to lose the value here, so let me just check on our player. Yeah, 280. Okay, so that'll be the max turn speed that the player will go, and this just basically we just have to change this a little bit. So as I was saying before, I want it to be kind of lerped, starting from 0 and then slowly increasing to the max turn speed. And one way to do that is to just kind of have a variable that keeps track of the time turning. So I'm just going to name it turning time, and basically I just want to keep track of the total time turning. So I'm going to say turning time plus equals time dot fixed delta time, since we're doing this in the fixed on fixed update. So that seems great. Now let's actually implement this lerping functionality. So I'm going to have another float, and this is going to be our turn speed. And this is going to be equal to, so the turning time, let's just say turning time for right now times our max speed, max turn speed. And obviously this isn't an ideal what we want right now. We want it, well, because the turning time could just keep increasing, and this would just increase the max turning speed forever. So I want this to clamp between 0 and 1. And let me check if I implement another variable here to, yeah, okay, so I'm just going to come back up here and actually put in another variable here. And this is the alert turn speed. So this is just a variable that determines how fast we're going from a turn speed of 0 to the max turn speed. So I guess maybe speed's not the ideal way to say that. Then it'd be the time it takes from going to 0 to the full turn speed. And let me see what I set in the code here quick. So I set a value of 0.5, so it takes half a second to go from the turn speed of 0 to the full turn speed. And I can set that now. So I'm going to want to do a function here to make sure that this turning time is clamped always between 0 and 1. So let me just do the min function for that and make sure it's clamped between 1, and this turning time is never going to be a negative value. So we only have to worry about the maximum. So this will make sure it's never greater than 1. And also I want to divide it by the lerp time to adjust how fast this time is being increased. So when turn time's a half second, this will be divided by 0.5, and that'll be 1. So then we'll get back to our max turn speed. Okay. So that seems good, and we can keep turn speed multiplied there, and that should be all we need, except for the fact that we need to reset turning time, because we need to reset it for every jump. So let me do that quick. So when we jump, we just want the turning time reset back to 0. Oops. Need to get better at switching between windows. Still getting used to that. So now we have this, getting a lot of variables here now, but now we have this lerp turn time, so this should nicely smooth out our turning movement. Let's check if that works. Okay, so that looks a lot better. This right now already feels very similar to how Getaway Shootout is implemented. In Getaway Shootout, there is a turn sensitivity setting, and I won't implement that right now, maybe do that later, but that's just basically multiplying by a certain factor of the turn speed. And that would be just right here. You'd multiply it by some other factors like turn setting speed here. But I'm just gonna, for right now, ignore those like player settings and perhaps get to that in a later video. Okay, so let me now just look back to the original source code to see if we're missing any other big changes that make it as close as possible to the original Getaway Shootout code. Okay, so I think the main thing left then that I've noticed is the balance function. This balance function works fine, and there's nothing bad about it. And the one case is maybe I can set it up in our scene. Yeah, maybe I'll just try doing that quick. Say if our player's maybe stuck under, I don't know, some big object. It could be another player even. Yeah, maybe I'll just make it another player. We want to make sure that this player can get up. Let's see. Yeah, in this case, it's trying to get up, but the torque added on that player is just not strong enough. And basically it gets stuck and it's unable to get up. So we want to increase the torque if we're just not moving for a long period of time. And the way I implemented this in the code is basically to have steps. So if we wait, let's say 1 second, and we haven't got to our destination of being upright, double the amount of torque. And then if another second goes by, triple the amount of torque, and so forth. So just creating these multipliers to slowly increase the scale. And, you know, thinking about it now, if I probably would do this again, I'm trying to copy the Getaway Shootout code as close as possible, but I mean, this is ideally what a PID does. You can look it up online. It's basically the integral term that integrates over time this air, so that this air accumulates over time, so you basically get a stronger signal. So we're going to actually kind of implement this just in like a rudimentary way of making sure over time that we increase strength if we're not there. So I'm going to add another variable to do this, and I'm going to call it balancing time. Basically, I want to know, or maybe I'm going to call it actually unbalanced time. So this variable keeps track of the total time that we've not been in the upright position, that we've been unbalanced. And the longer this variable, or the more this variable increases, the more power we want to implement. So pretty similar to an integral term. And the way I'm going to do that here is going to be, so if we're in contact and we're out of that range, we want to say we're unbalanced and increase that time. So time dot fix delta time. And that looks great. Now the only other thing is if we get into this zone, we want to reset this unbalanced time. So that's just this else statement right here. So we want to say unbalanced time equals 0. Now, just looking at this, I can simplify the code just a little bit, and I'll do that right now. Basically, we can get rid of this has damping variable and just use the unbalanced time. So here we're going to say it. Oops, Siri kind of Siri went off there. So if the unbalanced time is greater than 0f, so that means we've previously okay. If the unbalanced time is greater than 0, that means we spent time unbalanced, and we want to apply the damping now. So I'm going to copy this over and then set it reset here. So it's basically the same thing before, is that we just transitioned into using a float to make it more compact. So yeah, that just makes it easier to read now. And let's now test this. I guess we haven't used this unbalanced time yet as a factor yet, so let me just get that implemented. So the way, I'm just going to copy the way that I originally have this live in the code, is I do like something called an extra force multiplier. I'll just do mult. And I want to, well, I'll ignore that for now, but I want to basically use this unbalanced time and divide it by some increment. So as I was saying before, we can have it every second it increases the multiplier. And in the Getaway Shootout code, I have it every 1.2 seconds I increase this multiplier. This choice is just random here. You can change it, and honestly I could put it up here, but I think it's fine just to keep down here for right now as not a variable. And basically I want this in integer amounts. You could just have it something like this, but I just chose the idea of having it kind of forced to be an integer amount in discrete steps. And so we'll go with that since I did that in the original code. So this will just force this into integer steps. So basically from 0 to 1.2 would be 1, since this is a ceil function, always returns the highest integer. And then from 1.2 to 2.4, it'll be 2, 3. So this will now give us that kind of multiplier that I was talking before. Finally, the last thing, worst case scenario, if this increasing the force does not work, we just want to make sure that we don't go to something super insanely high. In the original code, I clamped this from obviously the starting value of a multiplier 1 to 4. This could be any large number that you want. I just set 4 here. So that's the largest extra force multiplier that can be applied. And so that should be good enough. So I'm just going to multiply it right here in our torque function. So balance power, and then I'm just going to add times the extra force multiplier. Okay, so that looks good. One thing I'm just noticing changed from the original code, and I'm just trying to make this as close as possible, just in case if you want to kind of have a duplicate of the original code. So this direction power, I ignore values greater than 9 degrees, or I guess I clamp them just because I don't know, like I said, that was the original way that I implemented it into the game. So I'm just gonna do the same here too. Again, if you're just following in this as like almost a tutorial, you don't need to do this. It's just something that I did in the original game. So I'm going to implement that in now. So I just clamp it between the 90-degree marks. So basically it'll never get bigger than 90 degrees. So that's that. So that should be pretty close to the original code now. Let me just check if that works. So same setup here. We have someone underneath someone. Let's see if they're strong enough now to get up. And we can almost count out 1 second, 2 seconds. So you can see it after that first increment multiplier, it finally gets the strength to go up. Again, you could implement this so many different ways. That's just one way that was implemented. and this kind of gives a good segue. So right now, we have two players in the scene, but they're being controlled from the same input. And this was obviously because we hard-coded the same input keys into the game. So both players are going to be the same input. So I think the next video would be a great time to implement the input system into the game. That way we can have one player, two players, and actually my plan is to straight off the bat have it as many players as you want using gamepads. So yeah, that'll be the next video, is to get that input system controlling the players. And that should be it for this video. That was the simple movement that we implemented in the game. You can definitely take this and go many different directions and kind of change it into your own interesting ideas. So yeah, thank you. See you next video.